Okay, so today we're going to look at 9.2, and we're going to split that into two sections. We'll look at part of it today, which is more of the stuff we do by hand, and then tomorrow we'll look at the part we use the calculator more, and also how what we're doing today connects with what we learned yesterday. Okay, we'll look at that tomorrow. Basically, everything we've done, even parametric, is based on a rectangular grid. Okay? What that means is anytime you graph something, you have an x value, and you have a y value. Okay? When you do something as a function, like y equals mx plus b, you create x and y coordinates. When you do something that's parametric, okay, like example 5, you still have x and y coordinates. The difference with parametric is you have two separate formulas for x and y. Well, today we're going to look at something a little different. We're going to look at a system that doesn't use x and y coordinates. Okay, it's called a polar coordinate system. And polar is handy depending on what you want to draw. If you want to draw things that are circular, polar is super easy. If you want to draw things that are straight lines, it's much better to use x and y stuff, either parametric or function. Those are both x and y. Right. So just to show you, let's say in parametric, if I wanted to draw a circle with a radius of 3, I would have to type in that. Okay. 3 cosine t for x, 3 sine t for y. And if I do zoom 6, it's going to look kind of like an oval because the screen is wide. But then I can fix it by just changing my zoom. And I get a circle with a radius of 3. If I wanted to graph the same thing in polar, I can type it in a lot easier than that. All I have to do is change my calculator to polar. And instead of typing in a 3 sine t and a 3 cosine t and all that stuff, I just type in one number, 3. Okay? And I get the same picture. So polar is a lot easier for a circle. Now I could show you just the opposite with a line. If I wanted to do a line, it's pretty complicated in polar. But if I wanted to do it really simple, I could put it back in y equals mx plus b, and it would look, you know how those equations look. Okay, so polar is good for some things, but not good for everything. Okay, that's what a polar grid looks like. Okay, so you can call it the origin, but a lot of times in polar we call it the pole. And it's like the origin. It's where everything starts from. Okay. So, did anyone use that kind of coordinate system before? Polar? Yeah, polar, it's a little bit different. I'm going to show you how the coordinates work. It's not an x and a y. It's based on an r and a theta. That's a coordinate in polar. We just have to explain what each one of those things means.
They use those in like world maps sometimes, right? Especially if the landscape's the Earth's curve and stuff like that, right?
Yeah.
I'm pretty sure that the coordinates on when you look at a map or a globe, that those coordinates are all like polar coordinates.
Do they use that? Or yeah? Yeah. Okay.
There's like polar north and then true north and all that kind of stuff, and they have different coordinates for each one.
Yeah, there's all kinds of different coordinates. There's spherical coordinates, polar coordinates, Cartesian is x and y.
I like x and y.
This is a cylindrical coordinate system. That's a little different. There's all kinds of different systems. So in polar, we call the first part r and the second part theta. Anyone have a guess what r stands for? Yeah, it's a radius. And how about theta? It's an angle. So when you're graphing something in polar, okay, the first number tells you a distance from the origin. So let's say the first number was 2. What that means is I'm going to go 2 units from the origin. If it's a positive 2, I would go right. If it's a negative 2, I would go left. And then from that point, I'm going to look at my angle. And my angle is going to tell me to move a certain number of degrees from the distance I moved based on r. So r can be positive or negative, and that controls whether you go left or right. Theta can also be positive or negative. What would that control? What do you think the two directions you can move in for theta are? It's not left and right.
Is it like diagonal?
No, it's not diagonal. Think about motion, circular motion.
What are those called? Revolutions?
And what would be the two ways you could move on a revolution?
Clockwise and counterclockwise.
You could go clockwise or counterclockwise. So R is going to tell you left or right. Theta is going to tell you clockwise or counterclockwise from the point you moved from R. Okay? It all depends if things are positive or negative. Okay, so if R is positive, you're going to move right. It's almost like an x coordinate. Right if it's positive, left if it's negative. If it's 0, well, you don't move. Okay, and then after you move either left or right, depending on if R is positive or negative, from that point, you're going to move a certain number of degrees. Either counterclockwise, if you have a negative angle, just like we've always done. Counterclockwise is always the I'm sorry, counterclockwise if it's a positive angle. I wrote it correctly on the board, I just read it wrong. Counterclockwise is when theta is greater than 0. Clockwise is when theta is less than 0. Okay, so step 1 should be kind of familiar from graphing x coordinates, and step 2, that should be a little bit familiar from when we did unit circle. We always moved in that direction for positive angles, and we always moved in this direction for negative angles.
So is R like the starting point of the turn, like the rotations?
Yep. Yep. So once you move left and right, it's kind of like when you have an xy coordinate. You move x, and then that's the starting point for the y. Okay, so the big thing we're going to do is just going to practice graphing points in polar. And then we're going to learn how can we take a point in polar and change it back to what we're used to, rectangular, and the other way around. How can you take a point rectangular and change it to polar? And then after we get good with working with individual points, then we can actually look at an equation. And that'll be tomorrow. Okay. Any question on what direction R tells you to move or theta? Okay. So, I don't think I have any polar graph paper. I just have regular graph paper. So you'll have to sketch that. If anybody wants polar, let me know. I could print some out and you could pick it up later on for the homework. Or really, you can just make one polar graph and you can put all your answers on one graph. Just label which dot is which problem. That's all. All right, so they want us to graph 3 45 degrees. Okay, I don't have any other grid lines on this graph, but a lot of times polar graph paper will have other lines on it. So like, I think this one is separated into 15s. So it's 0, 15, 0, 15, 30, 45, 60, 75, and that's 90. So it's separated for you. If it's not, we'll just estimate 45 degrees the best we can. Right, so 3. I'm going to start from the origin, and I'm going to go 3 units, which way? To the right. So I'm just going to temporarily put a little mark there. That's not my answer. That's just where I'm going to start from. Now I'm going to go 45 degrees from that point in which direction? Counterclockwise. Okay. And that's the answer. Okay, so right 3, 45 degrees counterclockwise. Okay. Any questions on that? All right, so now this one a little different. We've got a negative radius and a positive angle. Okay, so now from the origin, Ian, which way am I going to move based on the -2?
Left 2.
So we go left 2. And from there, am I going clockwise or counterclockwise?
You're going counterclockwise.
I'm going to go counterclockwise. How many degrees?
75, please.
75. So that's a little short of 90. Okay, so we went left 2 and then 75 degrees counterclockwise. Questions on that one? All right. Let's see, do I have any with radians? Yeah, we'll get to some with radians too. Okay, this time we have a positive radius and a negative angle. Okay, so John, can you tell me the first step to graph this one?
For the mark at 3 on the graph, to the right.
Yep, and go to the right 3. Now, every one that I've done so far has been a whole number. You can do 3.5 if it asked you to. You just go in between the 3rd and the 4th circle, right? So you can do decimals as well. So we went right 3, and then Curtis, I'm going to go 60 degrees. Which direction? Clockwise or counterclockwise?
Clockwise.
We're going to go clockwise. Okay, so if I went halfway, that would be 45. And then I'll just go a little bit more. Okay, so the answer should be about right there. Okay, if this was on the test and you put your answer, right here or right there, I'd pretty much give you credit for any of those. If you put your answer like up over there, I wouldn't give you credit for that. So it's got to be kind of close to where it should be in that spot. Okay. And if you're not sure, if you can't quite get it in the right spot, you can always draw in, a grid line yourself. Okay. If that was like 45, just go a little bit past it. Okay. All right. So this one now, it's a negative radius, negative angle. But if you're not comfortable with the radians, what could you do with it? Yeah, you could convert it to what? Yeah, so let's just convert that. So the radius is still -4. What's 3 pi or negative 3 pi over 2 in degrees? Negative 3 pi over 2?
Is it -270?
Negative 270, yep. Okay, so let's graph that one. So I'm going to start by going left 4, and then 270 degrees clockwise. So where's that gonna end up?
Bottom part would be the y-axis.
Yeah, it's going to be right on the negative y-axis on the 4th circle. It's going to be right here. Okay, this one, I'm going to draw how we got to that point. Okay, we went left, and then we went around that way. Can somebody give me a different way to get to that point? What would be another coordinate? John?
-490.
So -490. Yep. So that would be left 4 going that way. So there's another way to get to it. would be a third way?
Positive 4,
Yeah, we haven't done anything with a positive radius.
positive 4, and positive 270.
Yep. Positive 4, positive 270 would be like this. Positive 4, positive 270, and positive 4, negative 90. Positive 4, negative 90. Okay, so basically there's 4 different ways to get to every point in polar. You can go left or right. It's 2 choices. Then you can go clockwise or counterclockwise. There's 2 more choices. Can you do that idea in rectangular? Like if I want you to get to that coordinate. How many ways can you write the coordinate for that point? Only one. The only way to get to that coordinate is if you write this down. Right 2, up 1. Okay? So that's a big difference in polar. There's always 4 ways to get to every point. Now, you could also say something like, well, what if I went right and then went around an extra time to get to it? That's the same thing. Okay? Making extra revolutions doesn't really count as a different way to get to the point. You still went right and you still went counterclockwise, you just did an extra revolution. So 4 basic ways to get to every point.
Well, if you change that R coordinate, isn't there like unlimited ways to get to that point?
If you change R, well, if you change R, it's going to put you on a different circle. Yeah. So there's always, basically, if you look at it, you have a negative, 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 positive, positive, negative, positive, positive. That's the 4 ways. Okay, so that's important because if I ask you a question on a test, like if I give you a graph and say, what's the coordinate of that point, I would list one of these 4 as the answer, and then some other choices that would be incorrect. But you would have to be able to identify this point as any one of those 4. Okay, you have to know all the ways you could write it. Okay, questions on that? Okay. All right, how about 0 pi? Brad, what's going to be my first step there? Yep, we're going to remain at the pole, right at the origin. And then what about the pi? So where am I going to end up if I do that? Yeah, it's going to stay right at the origin, or the pole. The only thing you have to do when you're drawing it on the test is make sure, when you put your pencil, that you do that rotation in place. I'm going to look, I'm going to look for that. Just make sure you rotate in place, just like that. I'm kidding. You don't have to rotate in place. Just draw the point. Because you just rotate in place.
Mr. Hager,
Yeah.
take your day job.
Yes.
That is good.
Okay, I thought that
Thanks,
was pretty good.
All right, so it rotates in place. 0 comma anything is always going to be right at the origin. Okay, that's always going to be. What about if you switch it and put the 0 where the pi is? So you had something comma 0. It's always going to be on which axis? Yeah, it can only be on the x-axis, because this means go left and right, but then don't do anything from there. So this one is on the positive x-axis. Okay. Okay, any questions on that? If we have time tomorrow, I'll show you how you can draw a line in polar. Okay? Lines are very, very simple if you use y equals mx plus b. Lines are not that simple in polar. Circles are simple, but lines are not. Okay, so we'll take a look at that. We already graphed one that was a positive, positive, but any questions on how you would graph this one? No? Okay. So from the graphs we did, I'm just pointing out, make sure you realize there's more than one way to graph a point in polar. There's four ways. All right, so the last two things we're going to look at is how to convert polar to rectangular. Okay, both directions. Okay, if you're given a point in polar, what does that mean they give you? They give you an r, they give you a theta. If you want to change it to rectangular, you need to convert the r and the theta into a what and a y. You need an x and a y. Okay, so the goal converting in this direction is to change r's and thetas into x's and y's. Okay, so let's say we had a point right there, okay, and it's in polar. So I have the radius, which would be that distance. So that's r. Bless you. And I have theta. That's the angle. Okay, I would know those two things. Okay, what do you think I could do to this diagram, and we've done this a lot, to start to figure out what x and y would be, or to visualize it? Yep.
You draw a right triangle.
Yeah, I could draw a right triangle. So I'm just going to basically make a right triangle, okay, right there. So now that is my x, and that's my y. So now I just need to figure out a formula, okay, and we've done this a few times with vectors and other places. Formula for x and y. Okay, what trig function would I use that would involve the x, the theta, and the r?
You can use second, right?
Yep, that's the idea. So we just need to know which one of those three.
So y is opposite of the theta, right?
So we'll do y in a sec. Let's start with x.
Oh, okay. So x is adjacent of theta.
X is adjacent, and r is the
Hypotenuse.
hypotenuse. So what trig function has adjacent and hypotenuse in it? Cosine. So if I write cosine of theta, that would equal what over what?
X over r.
Yep, it would be x over r. And now I want to get x by itself so I can get a formula for it. So how would I move r to the other side?
R.
Yeah. So what would x be? R cosine theta. So if you have a point in polar and you want to convert the r and the theta into an x, take the cosine of the theta and then multiply by r. That's the x. And how about the y?
Y sine theta. End of being
Right?
R something.
R sine theta. You could set up exactly the same thing we just did here, except it would be sine theta equals y over r. Okay? Sine theta is y over r. Do the same thing, put the r on the other side. So there are your two equations to convert something in polar to rectangular. What trig function didn't I use here that is one of the three we use a lot? We didn't use tangent. Okay, we'll come back to that when we look at converting the other way. Okay, so here's a point in polar. So that's r, that's theta. They want me to convert it to rectangular. Okay, so what would be my formula for x, filling in what I have for r and theta?
r. So 2 cosine negative 200.
2 cosine negative 200. Yep. And what about for y?
2 cosine, or 2 sine negative 200.
2 sine negative 200. So just do both of those out and see what we get. Okay, you could be in radians or degrees. This particular problem is in which units? Yep, it's in degrees because we got the little circle. It doesn't matter if I put my mode in polar, function, or parametric because I'm not graphing anything right now. I'm just doing arithmetic. Okay, so I'm just going to type 2 cosine, and I know I need to change to degrees. So I'll change it. Okay, and we get an x-coordinate of negative about negative 1.80.
And y was 0.684.
0.684.
Yeah.
So, okay, anybody else get 0.68 for y? Right. So now we should just write our final answer. We really haven't written a coordinate yet. That's x. That's y. That's the final answer. Okay. Any question on that? I was going to show you something cool, but what I think is cool, I don't know, I lost all my confidence after that rotate and place thing.
It's okay.
All right, I'm going to try again.
I was like, one was good.
So I've got this point, right? 2, negative 200, and I just graphed it right here. So I went right 2, and then negative 200 means to go 200 degrees. That's 180. And then if I go one more, that's 15 more. So that's 195. And then I went a little past it. So any question on how that's the point 2, negative 200? All right, so now what I'm going to do is I'm going to take a rectangular grid, and that point is going to stay in place right there, but the grid behind it is going to change. And it should look like it's almost 2 units to the left and a little bit more than halfway up, about 0.7 up. Okay, so let's try it and see if that point lands where it should. So I need my background. And so we're looking for something that's about almost 2 units left and a little bit more than halfway up. Okay. Okay. So almost 2 units left and a little bit more than halfway up. So that point is exactly at the coordinates negative 1.9, comma 0.7, roughly. Yeah. So. Okay, yeah. That's pretty cool. Your Chromebook is not a touchscreen, so well, actually, you don't even have this software on it. So. You don't need a touchscreen, but yeah, you don't have the right software. You need a laptop. All right, let's try this one. Okay, what's my formula for x here? Three cosine 5 pi over 6. And it's perfectly fine to use 5 pi over 6 as long as you do what? Change your mode on your calculator to radians. If you don't want to change the mode on your calculator, then you could change that to degrees and keep the mode the way it is. But I would just change the mode. What about the y formula? 3 sine 5 pi over 6. All right, I'm going to start without the 3. I'm just going to type in cosine 5 pi over 6. Okay, so I'm going to do cosine 5 pi over 6. What is that number? Negative 0.866.
It is negative 20.
It's negative, well, as a fraction.
Isn't
It's a special fraction.
Isn't that negative 3 pi?
It doesn't have pi in it.
Oh.
That's the square root of 3 over 2, but a negative. Okay, so that's 3 times the square root of 3 over 2 with a negative.
Wow.
Okay, so if they ask for it as an exact answer, I would type in just the cosine part first, and you're either going to see 0.866 or 0.707. Those are usually the two decimals that come up a lot. And then you could just multiply it out like that. So we don't even need a decimal. But you do have to memorize that 0.866 is root 3 over 2. All right, let's do the same thing here. I'm just going to type in sine 5 pi over 6. Okay, see what that comes out to. This time we get a fraction, we get a half, and then times 3 is how much? Yeah, 1.5. Okay, so your coordinate is negative 3 root 3 over 2, comma, 1.5. If they wanted it as a decimal, just type, well, 0.866 times 3. See what it comes out to, and make it negative. Okay. But that's how you do it as an exact answer. The only time you can do it as an exact answer is when your angle is a multiple of what number? 30 or 45. And I know pi over 6 is 30. So this is a multiple of 30. It's 5 times 30. Okay. So any questions on converting to rectangular? Okay, so the last thing is converting the other way, to polar. All right, so in rectangular, what do they give you?
X, Y.
They give you an x and a y. And in polar, you want what?
R and theta.
R and theta. So now we're doing just the reverse. Okay, we want to convert an x and a y into an r and a theta. Okay, so let me, I'll sketch the diagram a little nicer than what I had. Okay, so I've got a, actually we don't even need a circle. We've got a coordinate right there. Okay, that coordinate is going to have an x and a y value, which we will know, like in this problem. Okay, you'll know the x and the y value. What do we need again?
R.
We need r. So I need to figure out the distance between that point and the origin. That's my r. And what else do I need?
Theta.
Theta. I have to figure out that angle. What do you think I'm going to do in this diagram like I did last time? James?
Pythagorean theorem.
Yep, we're going to do the Pythagorean theorem. But I need what shape first to be able to do that?
Triangle.
Yeah, I need a triangle. Okay, so I'm just going to make a triangle right there. There's my x. There's my y. And you will know both x and y. So to find r, you could use the Pythagorean theorem. Okay, and I have, I'm going to write this out nicely in a second. I have the steps right below it. But for now, I'm just going to put this here. And what about theta?
Won't that be,
You know this,
use,
this, and you want that.
yeah, opposite.
Yep. Y is opposite. What about x? Adjacent. What trig function would involve opposite and adjacent? Tangent. So the tangent of theta equals opposite over adjacent, but I don't want the tangent of theta. I just want theta. So how would I get theta by itself?
Tangent y, x.
So we do the inverse tangent. Okay? So that's how you find theta. And that formula will work fine if you are in quadrants 1 and 4. Because when we studied inverse tangent, we learned that inverse tangent always gives you a number between negative 90 and positive 90. Okay, well, what that means is negative 90 is down in quadrant 4, positive 90 is in quadrant 1. So you're always stuck in that half. But we could get points that are in quadrants 2 and 3, like the point negative 4, 6. So we have to make a small adjustment to that inverse tangent if you end up in quadrants 2 or 3. So the first step I put down is to graph the point. But really, all you need from step 1 is what is the quadrant you're in. If you can determine the quadrant without graphing it, then graphing isn't necessary, unless the problem specifically said to do that. Okay, but the point is, step 1, determine the quadrant you're in. So to find theta, if you are in quadrants 1 or 4, you do exactly the formula I just showed you. If you're in quadrants 2 or 3, you're still going to do the inverse tangent of y over x, but you have to add pi if you're in radians. If you're in degrees, you'd add 180. Okay, so quadrants 1 and 4, just use inverse tangent y over x. Quadrants 2 and 3, it's 180 plus inverse tangent y over x. Now, even this doesn't cover everywhere you could be. Where else could you be besides quadrants 1, 2, 3, or 4?
Along the axis.
Could be on an axis. And if you're on an axis, you don't have to use these formulas to find the coordinate. And if you tried to, you'd have a problem. If I asked you the coordinate of that point, what's the x value? 0. And the y value?
90.
Well, let's pretend, there's my marks. What the y value in that case is 1. If x is 0 and y is 1, what happens if you plug a value of 0 in for x?
It doesn't work.
Why?
You can't have a 0. That's like the bottom.
You can't divide by 0,
Yeah.
right? So the same thing would happen down here. Okay, so if it's on an axis, you don't use one of these formulas. Okay? You just have to memorize that the answer is one of those 4 numbers. If you're here, it's 0. That's 90. That's 180. That's 270. How do you know if a coordinate is on an axis? What's special about coordinates that are on an axis?
Well, they have a value that's 0.
They have a value that's 0 somewhere. It's either 0 comma something or something comma 0. So anytime you have a coordinate with a 0, I don't here, well here I do. So anytime you have a coordinate with a 0, you know you're on an axis. Okay?
Did we do something like this before, Mr. Hager, where you said,
Yeah, the unit circle.
oh yeah.
With the unit circle, yeah. And then the last step is to find your radius. Okay? And that you just use the Pythagorean theorem. Okay? That's what we wrote, I think, up above. Yep. And that formula is the same no matter what quadrant you're in. R squared equals x squared plus y squared. All right, so let's see if we can convert that point to polar. All right, so let's start with finding the angle. What quadrant is that point going to be in?
4.
4. Yeah, it's right and down, so it's somewhere in quadrant 4. And what is the formula to find theta if you're in quadrant 4? Inverse tangent
Times 1 over x.
of.
Oh.
Yeah, so that's the number you're plugging into the function. There's no multiplication there. What would go on top? Y over x. Okay, so type that in, and then you'll know your angle. I'm expecting to get an angle that's negative because I'm in quadrant 4. Okay, it could be like negative 60 or somewhere in that area. So inverse tangent of negative 5/3. I'm going to do this one in degrees. All right, so we get negative 59.0. Okay, if we want to round, be accurate to the nearest tenth. Okay, so we've got our angle. And what would be my equation to find r? Squared plus negative 5 squared equals r squared. So that's going to give me 9 plus 25, which is 34. And my last step would be to take the square root. So my radius is the square root of 34, and my angle is 59.0 degrees. Now, how many different ways are there to write this answer? Four. What's that? Yes, negative 59. Right. This is with a positive radius, negative angle. There's 3 other ways you could write it, which we've already gone through. Okay, and the last one, this one should be a lot faster because the radius and the angle are both very easy to find. You don't need any formulas. What's the angle if you go right 6 units? I'm sorry, this is up 6. Left and right 0, up 6.
90.
So that's a 90-degree angle. And then if you graph a point that's up 6, how far is that point from the origin? 6. Right? If all you do is go straight up 6 units, you really don't need the Pythagorean theorem to find the radius. Any question on the radius or angle? So in polar, you went 6 units and then 90 degrees counterclockwise. And that's your point. Okay. 3 other ways to write that. And then if you include all the ways you could do it in radians, you could do it 4 more ways. But that's just changing degrees to radians. Okay. So any questions on converting polar to rectangular? Okay, so that pretty much wraps up everything that we're going to do for just looking at individual coordinates. Tomorrow, we're going to use the graphing calculators a lot more to play around with parametric and polar. Yeah, the homework just 1 to 14 on page 492.